Good morning, children. Today we'll learn this chapter, metals and non-metals, a lesson from chemistry. You may be knowing elements are basically classified into metals and non-metals. How you can define metals? Usually these are the elements which form positive ions when they lose electrons. Okay, there are many examples. Few I have listed here: copper, iron, aluminum, sodium, etc. Okay, let us learn how they form positive ions. Something like this. Okay, I consider the example of sodium here. Whenever sodium loses an electron, it gets charge. Any atom getting charge, we call it as ion. Remember that. Okay, now as it has got positive charge, we call it as cation. In the later part, we are going to discuss a little deeper into it. Okay, what is cation? You can define it in two different ways. One way is the ion containing positive charge. Other way is the ion which is attracted towards the negative end of the battery, that is cathode. Any ion which is attracted towards the negative end of the battery, that is cathode. So that is actually called as cation. Okay, usually metals become electropositive whenever they lose electron. Remember this. So that's why metals are called electropositive. They lose electron, at that time they get positive charge, means they form cations. Remember that. Okay, now let us learn the physical properties of metals. Okay, first is metallic luster. Do you know lustrous? Metals are usually lustrous. Lustrous means they have bright shiny surface. Okay, most of the metals, they have bright shiny surface. Okay, example, for a few metals which are really known for their metallic luster, one is silver, gold and platinum. You might have observed them, they shine. This is one of the reasons why they are actually used to make ornaments. Okay, the next physical property, metals are hard. And here we have used the word most of the metals. Okay, so why I have used the word most of the metals? That is because there are few exceptions. Not all metals are hard. There are few metals which are soft. So that is the reason I have used the word most of the metals are hard. Now, there are few metals like lithium, sodium and potassium. They are also known as alkali metals. You know the special feature of alkali metals? These metals can completely dissolve in water. When they are added to water, they can be dissolved in water. So that is why they are called as alkali metals. Okay, so these alkali metals, that is lithium, sodium as well as potassium, they are so soft, they can be cut with the help of a knife. And remember, even they have low density as well as low melting point. You know what is density means? Density always indicates how closely the atoms are arranged. Suppose the atoms are actually arranged little far away. At that time we tell they have low density. Okay. Now, melting point. The temperature at which a solid is converted into liquid. So that is called melting point. Even for lithium, sodium and potassium, it requires a little low temperature to convert them from their solid state to liquid state. So we call they have low melting point. Okay, then third nature, ductility. Do you know what is ductility means? Even metals can be drawn into wires. So this nature of metals, this nature of metals in which we can draw them into wires. So that's why it is called as ductility. Okay, then do you know which is the most ductile metal? It is gold. Okay, it's one very interesting fact has been given in your textbook. 1 gram of gold can be used to draw a wire up to 2 kilometers, it seems. That's very special. 1 gram of gold. We can make a thin wire which can reach a distance of 2 kilometers. So that's very special. Okay, so you should know what is ductility means. Ductility means metals can be drawn into wires. So this nature is called ductility. Which is the most ductile metal? It is gold. Then fourth important physical property, malleability. Do you know if metals are actually hit with hard object like hammer, they become flat and they can be converted into sheets. So this ability of metals, okay, to form thin sheets. So this is called malleability. Okay, so we can write metals are malleable. Okay, do you know which metals are highly malleable? One is gold, Au is gold, Ag is silver. Gold and silver are most malleable metals. Remember this. Okay, so because of one is actually lustrous nature, other one is ductility, other one is malleability. Because of these special physical properties, gold, silver and platinum, they are used to make ornaments. The later part we are going to learn in detail about them. Okay, now, okay, malleability means ability of metal to form thin sheets. Remember that. Okay, so gold and silver, these are most malleable metals. The next important physical property, good conductors of heat. Do you know metals are very good conductors of heat? Okay, compared to what is that, non-metals. Metals are very good conductors of heat, and that too copper and silver, these are best conductors of heat. Okay, whereas lead and mercury, Hg is mercury, these are poor conductors of heat. So copper and silver are best conductors of heat. This is one of the reason so why copper and silver are used in cooking utensils. But nowadays silver is not used or less used because they are expensive. Okay, otherwise earlier days silver containers were being used, so mainly as cooking vessels. Okay, then lead and mercury, these are poor conductors of heat, means they may allow the heat to pass through but very very minimum. Okay, best conductors of heat if they ask, you need to know copper and silver. Next physical property you will be learning, metals are good conductors of electricity. Do you know what is good conductor of electricity means? They allow the current to pass through them. Remember, and that too with a specific reason. Metals have free electrons with them. So that is a main reason so why metals are called good conductor of electricity. So these free electrons will help the metal to carry the current from one side to the other side. Then, do you know metals to have high melting and boiling point? So their melting point and boiling point is very high in the case of metals. Let me tell you what exactly this melting and boiling point is. See here. Okay, the temperature at which solid is converted into liquid, we call this as melting point. Remember, the temperature at which solid is converted into liquid is called melting point. Okay, now what is boiling point? The temperature at which liquid is converted into gas. So this is called boiling point. The temperature at which liquid is converted into gas is called boiling point. The temperature at which solid is converted into liquid is called as melting point. Remember. Okay, now, so metals have very high melting and boiling point. Do you know tungsten is the metal with the highest melting point? Among all the metals, the highest melting point tungsten has. Do you know the symbol of tungsten is W? Okay, then gallium and cesium, they have low melting point. Do you know their melting point is so low, if you place gallium and cesium on our palm or on your palm, okay, gallium is Ga, cesium is Cs. Do you know at our body temperature itself it will start melting? So if they ask you, so name the metals which can melt at our body temperature, your answer should be gallium or cesium. Even if they ask you, so name the metal so which will start melting when it is placed on our palm, your answer should be gallium and cesium. Remember that. The last important physical property, sonority. Do you know what is sonority is? Metals are sonorous, means they have the ability to produce sound. Okay, typical metal like sound we can hear. So this property of like metals are actually used to make school bells. Even it is used to make school bells. So these are the very very important physical properties we have learnt related to metals. Let us learn these activities related to physical properties of metals. First is activity 3.1. Okay, you can keep your textbook with you so that it is clearly visible. As the fonts are a bit smaller in size, it may not be very clear for that reason. So activity 3.1. So this activity is actually conducted just to show metals are lustrous, means they have shiny surface. Here we need to take the samples of iron, copper, aluminum and magnesium. Okay, we should check their surface, how it is. Suppose if it is very old, if it is kept in one particular place for a long duration of time, they may not appear shiny because they will have some oxide layer on their surface. So due to that, they may not be very shiny. They may appear little dull. Okay, we tell they might have corroded. So what we do is we'll take a sandpaper and we'll rub. Okay, we'll take a sandpaper and we'll rub these iron, copper, aluminum and magnesium sample. As soon the oxide layer is actually removed, do you know it will start appearing shiny or lustrous. So this indicates metals are lustrous. Remember, here we are using sandpaper mainly to remove the oxide layer. Okay, then so we have one more activity, that is activity 3.2. In this activity, we'll show metals are hard as well as few metals are soft. We need to take small pieces of iron, copper, aluminum and magnesium. Okay, we need to try to cut these metals with a sharp knife. When we use a knife to cut iron, copper, aluminum or magnesium, so we can observe they're very hard, not that easily they can be cut. Okay, whereas if we take sodium metal, okay, suppose if we take a piece of sodium metal and if we try to cut with the help of a knife, easily it can be cut. Remember, sodium, lithium and potassium. So these three alkali metals can be cut easily with the help of a knife. Then, so next we'll learn about activity 3.3. So this activity will actually show malleability nature. Okay, now we need to take pieces of iron, zinc, lead and copper. What we need to do is we need to hit that with a hammer. Then we need to observe what will happen. Whenever we hit, especially iron, commonly you might have seen, when we hit that with the like hammer, they become flat. Means they can be converted into sheets. So this nature of metal to become sheets, iron, zinc, lead and copper, so we call it as malleability. Remember, okay, they change their shape. So that is malleability nature. Then here like activity 3.4, it is given list the metals whose wires you have seen in daily life. Okay, so which metallic wires are actually we have seen. This is mainly to show ductility nature. That is, metal can be drawn into wires. We have seen iron wire, copper wire, aluminum wire, even lead wire that is actually used for soldering and all. Okay, so this indicates metals are ductile. Then there is another activity, activity 3.5. Okay, in this activity we will show that metals are good conductor of heat. So we need to take a stand. We can use either aluminum or copper wire that should be fixed to this particular stand with the help of a clamp. Okay, then one end of this aluminum or copper wire should be one end of this particular aluminum or copper wire. Okay, to that region we'll place a pin. How? With the help of a wax. With the help of a wax we can place pin at the terminal region, tip of this aluminum or copper wire. Now with the help of a burner we'll start heating. If metals are good conductors of heat, this heat should transfer from here till this region. Okay, do you know when we start heating, after some time this pin will fall. Why the pin will fall? Because the wax will melt. Now why the wax will melt? Because when we use this burner to heat this metallic wire, the heat will transfer from this end to this end. So this experiment proves that metals are good conductors of heat. Okay, now one more last activity related to the physical properties of metal. Activity 3.6. Here we need to take a battery, okay, bulb, switch, then wire, conducting wire. Okay, then so at the tip of two wires here, clips are actually arranged, clips. Okay, so like a battery will supply the power, means current. Now when we turn this particular switch on, current will flow in this particular circuit. We are making a circuit with the help of battery, bulb, switch and by using wire. Now just imagine this is the metallic sample we have here. You can make it. So this is the metallic sample we have here. So this one should be placed between A and B. So this metallic wire sample. Now we will turn the switch on. When we turn the switch on, the bulb will glow. What that indicates? That indicates metals has allowed the current to pass through them. Means metals are good conductors of electricity. Suppose if metal is not a good conductor of electricity, when we use this metallic sample between A and B, the bulb shouldn't glow. Like indicating it is not a good conductor. But what happens whenever we use a metallic wire, a metallic sample, at that time the bulb will glow, indicating it has allowed the current to pass through it. So these are the very important physical properties and activity we learnt in today's class. Thank you.